In this recording, we're going to go over a one-step dimensional analysis to convert metrics. So let's do example number one. First thing I need to solve for is the metrics, or the conversion factor. So let me just do this. So the Grand Master King Henry died by drinking chocolate milk underneath people's feet. So kilometers to meters is going to be a base unit to kilometer. So they'll make this 1. So every step is going to be by 1. So this is 10 to the first, 10 to the second, and 10 to the third. All right. Now, just to remind you, the steps here, between here and here, are by 1 exponent. But then if you go up here, like the step to here, the step here, the step here, they're all by 3s. And the same here. So the step from here to here is 3, the step from here to here is 3, and so on. Anyways, what I have figured out is that 1 kilometer equals 10 to the third meters. All right, so then I'm going to start my problem, 200 kilometers. I'm going to use my dimensional analysis. So dimensional analysis is basically using this conversion factor. I'm going to choose to take this side of the conversion factor and put it below here. The reason why I chose this is so that it will cross cancel. So we want these to cross cancel. If I chose to put the 10 to the third meters on the bottom, then the kilometers would not be able to cross cancel. So as a result, since I put kilometer at the bottom, I have to put meters up top. So the key here is just make sure that they're across from each other. And where did I get this? Well, this comes from my conversion factor. Then my units will be left in meters. So if you look, the only remaining units that cross cancel the kilometers is meters. I just have to do the math. 200 times 10 to the third meters. And then it's all over 1, right? Because here's your 1. We know that to just be 200 times 10 to the third meters. 200 is not good coefficient for scientific notation, so it'll end up being 2 times 10 to the 5th meters. All right. Let me do one more with you. So let's do the next problem. So we're going from milligrams to grams. So let's go ahead and figure out the conversion factor. So if you do the conversion factor, you'll find that 10 to the third milligrams equals 1 gram. And then from that, we'll start our problem, the 310 milligrams. Now, since you have milligrams here, you're going to have to put milligrams on the bottom. So this will be the denominator. This will allow you to cross-cancel these 2 units, and then 1 gram up top. So if you solve this, it'll be 310 over 10 to the third grams. Well, what's 310 divided by 10 to the third? Well, if you find an exponent in the denominator, to move it up to the numerator, mathematically this worked, but to move up to numerator, when you divide the exponent, you just end up subtracting it. So this becomes a negative 3 grams, and ultimately it would be 3.1 times 10 to the negative 1 grams. How does this work? So that's, if you want to remember it becomes a negative or you flip the sign, that's fine. But let me just show you how it works. So this problem actually looks like this in scientific notation. 310 is equal to 310 times 10 to the 0. You're dividing it, right, by 10 to the third, which is 1 times 10 to the third if you want to add a coefficient. So if we're doing this math, 310, let's deal with the coefficient. 310 divided by 1 is 310. And then 10 to the 0. So when we divide exponents, we subtract them, right? So it's going to be 0 minus 1, which equals 310 times 10. Oh, let me move it. I didn't realize I was going there. So that equals 310 times 10 to the negative 3 grams. And that's how I got this number. All right. hopefully that helps.